Welcome to the Explainer. I am so incredibly thrilled you're here today. We're going to take a topic that totally intimidates a lot of people, SQL window functions, and we're going to make it so simple you'll wonder why you ever stressed about it. If you've ever stared at a massive complex SQL query and felt completely overwhelmed, just take a deep breath. You are in exactly the right place. Think of me as your personal tutor. By the end of our time together today, you're going to understand these tools so clearly, you'll actually be excited to use them. Let's dive right in. Okay, so imagine this scenario, and it's a super relatable one. Let's say you're a teacher. You've just finished grading all your students, and you want to look at each student's individual grade, but you also want to see the class average sitting right next to it for comparison. Sounds easy, right? Well, normally in SQL, if you calculate an average, it immediately collapses all your beautiful data into one single summary row. To get both the individual student and the class average, you'd usually end up writing these massive, messy subqueries that are an absolute headache to read and really slow to run. It's the classic data dilemma. And honestly, we've all been that confused beginner, sitting at our keyboards just wondering why it has to be so difficult to just keep our rows while doing a little bit of math. But don't worry, because this is exactly where our hero enters the story, the window function. It is the absolute perfect stress-free solution to this exact headache. It's a total game changer. So, here is our roadmap for today. We'll start with the window superpower, break down the magic syntax, and then explore the three main function families: aggregate, ranking, and value, one easy step at a time. Section 1, the window superpower. What makes these functions so incredibly special? Well, here's the deal. Regular aggregate functions, like your basic sum or average, take a bunch of rows, squish them all together, and spit out one single result. You totally lose all those individual row details. But a window function, it performs that exact same math, but it brilliantly preserves every single row in your data set. It just neatly tacks the calculated answer right onto the end of each existing row. You get the big picture math without losing the tiny details. That right there is the superpower. Section 2, the magic syntax. Let's look at how we actually write one of these. I promise the syntax is so much simpler than it looks. It's basically a recipe with three ingredients. First, every window function absolutely needs the over clause. That is the magic word that tells SQL, hey, open a window for me. Inside those parentheses, you have two tools that are technically optional, but you're going to use them all the time. There's partition by. Think of this exactly like a group by, but without deleting your rows. It just logically divides your data into little buckets so it can do the math. And finally, order by. Just like it sounds, it simply lines up your rows in a specific sequence inside those buckets, and that's the whole shebang. Now that we have the syntax down, you should know these functions basically live in three distinct families: aggregate, ranking, and value. Let's start with the one you're probably already the most familiar with. Section 3, aggregate functions. It's the math you know, just with superpowers. Let's walk through this query together, just reading it in plain English. We are taking the average of a student's grade. But instead of a regular average, we add over, and inside the parentheses we say partition by subject. We are literally just telling the database, hey, calculate the average grade, but do it specifically for each individual subject, and stick that average next to every single student's row. And boom, here is the aha moment. Notice how Alice, Bob, and Charlie, they get to keep their own unique math grades. Alice has an 85.5, Bob has a 90. But thanks to our newly minted window function, the overall math average of 83.50 beautifully sits right next to their names. It makes comparing an individual's performance against the whole group absolutely effortless. No subqueries needed. Section 4, ranking functions. Figuring out exactly who is in first place. Now, there isn't just one single way to rank things in SQL. You get a whole toolbox to play with. Row number, rank, dense rank, entile. We're going to focus on the absolute most useful ones, starting with the easiest way to give rows a sequential order. Row number does exactly what you'd think. Here, we partitioned our employee data by department and ordered it by salary descending. So over in the IT department, Charlie gets handed name tag number 1, David gets name tag 2. Then the magic happens. Because we partitioned by department, the very moment we drop down to the HR department, the counting completely resets. Alice gets a brand new name tag 1 and Bob gets 2. It just hands out sequential numbers, resetting for every single new group. But wait, what if people have the exact same salary? This is a tricky little difference that catches a lot of beginners, so let's clear it up right now. Rank versus dense rank. If two people tie for second place, Rank says, okay, you're both second, but then it actually skips the number 3. The very next person in line is fourth. It leaves a gap in the numbers. Dense rank, on the other hand, never skips. The tiebreakers are both second, and the very next person is third. It keeps the ranking densely packed. Before we leave ranking, I have to show you N-tile. Let's say our teacher from earlier wants to automatically divide a class into 3 buckets: high, middle, and low performers. By just using N-tile 3, SQL automatically divides all your rows into 3 roughly equal groups. Group 1 gets the top grades, Group 2 the middle, Group 3 the lowest. If you ever need to group data into quartiles or percentiles, this is going to be an absolute lifesaver. Section 5. Value functions, also known as time travel in SQL. The functions in this family, specifically lead and lag, are complete game changers. If you're doing any kind of financial reporting, tracking month-over-month sales, or looking at stock prices, these are the tools you're going to reach for every single day. Let me paint a really clear picture for you. Imagine you're currently standing in the month of February, looking at your sales data. Lag acts like a literal time machine looking backward. It lets you peek up at January's data and pull it directly into February's row. Lead is the exact opposite. It looks forward into the future, fetching March's data and bringing it back to February. So you can compare the past, the present, and the future all sitting neatly side by side in one single row. There's one more highly specific tool in this family called NTH value. Because sometimes you don't want the first value, we don't want the last value, and you aren't just looking 1 month ahead. What if you want to compare everyone to the person who made exactly the 3rd highest sale in the entire company? That's what NTH value does. You just give it the column and the number you want, in this case 3. Let's actually see that in action. Here we've ordered our sales from highest to lowest. Eva is first, Alice is second, and David is third, with a sale of $8,500. NTH value effortlessly reaches right in, pulls out David's $8,500, and pastes it next to literally everyone else's row. Now, Eva can see exactly how far ahead she is from 3rd place, and Bob can see exactly what target he needs to hit to grab that bronze medal. It is incredibly powerful. So you now officially have the superpowers needed to do some amazing things, like calculating a 7-day moving average or finding the 95th percentile of server response times. So I have a question for you. What hidden insights are currently trapped inside your own datasets, just waiting for a window function to set them free? Open up your SQL editor, test out your brand new powers, and find out. Thank you so much for joining me for this explainer.